All right, let's record this video together. The focus is just one, to be able to find the LCM of a number, of a group of numbers properly and correctly. Now, let's do the correction for this. Now we have, okay, we have 8, we have 5, we have 10, and we have 2. All we have to do is look for their factors, the numbers that make them of that. We can use to multiply them, and we need to break them down to as small as possible. So we have 2 times 2 times 2 for this one. This one is just 5. You can put 1 times 1 there, but there's no matter. It doesn't matter at all. Then this one is 2 times 5. And this is just 2. Now we need to make sure that we have the same number everywhere. Now this 2 here is missing 5, so we have times 5. That's the only thing is missing. It has the 2 here. The 2 here is already here. The 2 here is already on this side also. And the 2 in 2 times 5 is already here. So we have 2 times 5 here. So we need to bring the same thing to the other side. Now what James is missing is missing times 2, times 2, and times 2. Here is missing times 2, times 2. Here is missing times 2, times 2, times 5. So now our answer will be 8 times 5, which is 40. Same here, 40. Same here, 40. Same here, 40. Therefore, that's our LCM. We are done with that. Okay, let's move to the next one. Now, this one says, it's just general. This one is another one. It's about prime factorization. We have 190. 190. So to do prime factorization, 190. Let's just start from something small. So if you have 190, we are doing prime factorization. All we have to do is 19 times 10, because that's 90. Then we can break further and say 19 times 2 times 5. We can break any lesser than this. Then we cannot arrange it properly from lowest to biggest by saying 2 times 5 times 19. I think that's the only problem here. That's the only correction here. The only correction there is that you should arrange from the least to the greatest, not haphazardly. From the least to the greatest. That's settled. Then the next one we have, oh, same thing. This one is almost the same thing, but let's explore it together. We have 144. 144, let's start with 144. That's 12 times 12. Then that's 4 times 3 times 4 times 3. Then we can have 2 times 2 times 3 times 2 times 2 times 3. Then we cannot arrange everything properly. We have 2 times 2 times 2 times 2. All the 2's are gone. Times 3 times 3. So we have 1, 2, 3, 4 2's and 1, 2, 3's. Make sure you don't have any number that has a factor. You have to make sure that everything is brought down to the least factor, and make sure that the number is not divisible by another number. That's the easiest way to sort out prime factorization. That's the easiest way. That is the easiest way. Okay, moving on. Oh, what problem? This is the only one. So it says Isaac is making emergency preparedness kits to share with his friends. He has 40 bottles of water. He has 40 bottles of water and 32 cans of food, which he would like to distribute equally among the kids. With nothing left over, what is the greatest number of kids he can make. So he wants to put 40 in a group and also 32 in a group. So we need to look for a number that is in between 40 and 32. That means the combination of how many 40s can be in a group and how many of the 40 bottles rather can be in a group, how many 32 cans can be in a group. Now, instead of something I said about that, since he wants to share it, best thing, what we have to do is just look for GCF. Yes, look for GCF. We look for GCF of 32 and 40. So let's break down the same way we did before. That's 32. We have that's 2 times 16. Then we can bring down further and say 2 times 2 times 8. Can bring further and say 2 times 2 times 2 times 4. Further by saying 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. Then the 40, we have 4 times 10. That's 2 times 2 times 10. That's 2 times 2 times 2 times 5. Now let's look for the common numbers, the common factors in this part and this part. We are focused on the last part. So we have a 2. We have a 2 here too. We have another 2 here. We have another 2 here too. We have another 2 here. We have another 2 here too. So we have 3 twos. That means GCF equals to 2 times 2 times 2. You can add times 1 also. You can add times 1 also. So equals 2 times 2, 4. 4 times 2, 8. 8 times 1 is still 8. So the answer is 8. I hope you understand this. We'll keep doing corrections like this until you get it. Stay tuned. See you in the next one.